So this will be your last lesson on trigonometry. So we've got two lots of trigonometry or trigonometric equations that we've got to look at. Okay, so first ones, as we can see from the question, the big thing that's changed here now is we are looking at cos 3x rather than just cos x or sin x. Okay, so we've changed the input. We've still got a range that we have to work between. Now, whenever you are given one of these, and it isn't just x that we're looking at, the first thing we need to do is adjust our range. Okay, so at the moment, if x is between 0 and 360, what I now need to look at is 3x instead. So all I'm going to do to my range is just times both bits by 3 to make it 3x rather than x. So I'll have x is between 0 and 1080 instead. Now I can go through the same process as usual. So using my equation, I know to get rid of cos, I'm going to inverse cos both sides. So I'm going to have 3x equals cos to the minus 1 of minus a half. And I can solve that. So I'll have 3x equals 120. Now, as we looked at before in the last lesson, we have multiple answers to these. Okay, so that is just the principal value. So we've got to go back to our trig graph. We know we're now looking at cos, so if we have a quick look at our cos graph, I'm going between 0 and 1080. Okay, now the first principal value is there at 120. So I need to find, first of all, this value. Now I know that cos will repeat every 360 minus x. So I can find this value in here, which must be 240. Okay. Now, because this is going to go on and on and on, it's just going to repeat every 360. The second thing I need to think about is repeating every 360 degrees, all the way up to 1080. Okay. So all I'm going to do is keep adding 360s on to both of these, and I will get all my solutions. So 360 onto the 120 to give me 480, 360 onto the 240 to give me 600, and then we'll go again. So 360 onto the 480 will give me 840, and 360 onto the 600 to give me 960. Now if I added 360 on again to the 840, I would go above my 1080 limit. Okay. However, at the moment we've got 3x lots of it. So to find x, I'm just going to divide each one by 3. So I can have 40 degrees, I can have 80 degrees, I can have 160, 200, 280, and 320. And as we can see, all of our answers here should now be within my initial range. Okay, so first thing we've got to do is adjust the range. Okay, then solve the equation as we would do before. Okay, making sure we find all values in our range. Okay, so use the fact that cos or sine or tan repeat, and then we finally find x. Okay, so let's just have a look at another one. So this time we've got sine 4x equals root 3 over 2. This time we're going between 0 and 180. First thing, always, is to adjust our range. Okay, so I'm looking at 4x now instead. So I've got to times both my ranges by 4. Okay, so 0 will obviously stay as 0. 180 changes to 720. Right, solve the equation. So we'll know that 4x is sine to the minus 1 of root 3 over 2. Therefore, 4x must equal 60. Okay. Again, that's just the principal value. I'm looking at sine, and I'm going all the way between 0 and 720. So effectively, I've got two lots of this, haven't I, to go between 0 and 720. So you can always draw out your graph as long as you want to. Okay, or we can just use the fact that it's repeated. My first answer of 60 is in here. So the first thing we need to remember is we're now using sine. So sine instead it repeats on 180 minus x rather than 360 with cos. So I know this one in here should be 120. And again, the other repetition for sine is it repeats every 360. So exactly the same as we did for the last one. We're just going to keep adding 360s on until we get past our 720. So I'll add 360 on and get 420. Add 360 onto my 120 and I get 480. Now if I added 360 onto my 420, I would go above my 720 limit. So that's all of my solutions that I need. Finally, I need x rather than 4x, so I'm going to divide everything by 4. So I'll have 15 degrees, 30 degrees, 105 degrees, and 120 degrees. Okay. What you've got to remember, guys, is first of all, you've got to adjust your range. Then we can solve as we would do normally, making sure you find all of your values in your new range. Okay, and then just finish off simplifying afterwards. The next one I just want to show you is small linear equation, okay, within here. Now all that means is when I change my range, which at the moment is between 0 and 360, now I want to change that to 2x plus 30. So I've got to think about what I do to 2x plus 30, to get to 2x plus 30. So what I'm going to do is I'm going to times all my values by 2 and then add 30 to them. Okay, so 0 times 2 is 0, add 30 will give me 30. 360 times 2 will give me 720, and then I add 30 on to that, and that will give me 750. So that is now my new range I'm working between. Everything else works the same. So to get rid of sine, I'll do sine to the minus 1 of it. So I'll have 2x plus 30 equals sine to the minus 1 of 1 over root 2. So 2x plus 30, just work that a little bit out, should be 45. Okay, again, we can use our graph. So we're doing our sine graph. Okay, and we're going up to 720 this time. Okay, so principal value is 45 in here. As with the one above, we repeat every 180 minus x. So that means my second value will be 180 minus my 45, which will give me my 135 degrees, which is going to be that one there. And then we know we repeat every 360. So I'm going to add 360 on again until I get up to 750. So add 360 on will take me to 405. And 360 onto my 135 will give me 495. If I added 360 on again, I would go above my limit of 750. Okay. Now all we've got to do is we've got many linear equations to solve for each one. So you solve it each time. So we'll do 2x plus 30 equals 45. So 2x will equal 15. So x must equal 7.5. We do the same with the next one. So 2x plus 30 is 135. So 2x is 105. Therefore x is going to be 52.5. Same with 405. Subtract 30, divide by 2. Give us 187.5. And same with the last one, 495. Take 30 off, divide it by 2 to give you 232.5. Again, just double check quickly, all of my answers are within my range here, so I am quite happy. Okay, slight difference just in the fact it's got a linear equation, so you've got to be careful when you create your initial range. Okay, make sure you follow on what you should do. So for 2x plus 30, I times each by 2 and add 30. Okay, rather than just timesing by a number. And then we follow the same process, and you'll have little equations to solve at the end to find each value. Okay, right, what I want you to do, you've got 2 there to have a go at for me. So pause the video, have a go at both of those, and then we will go through the answers. So let's have a look through these ones then. So first one, cos 3x equals a half, and we've got our range between 0 and 360. First thing always to do is to adjust our range to what we are working with. So we're working with 3x. So I'm just going to times both things by 3. So I'll be working between 0 and 1080. Right, we now need to solve our equation. So I'll do inverse cos of both sides. So I'll have 3x equals cos to the minus 1 of a half. So I know that 3x must equal 60. Remember guys, it's important now we find all of our values in the range. Okay, so I've got my little cos bucket and I've got to think about where I repeat. With cos, our repetition, if my first one is here, my second one is here, I repeat every 360 minus x. Okay, so that means my second value must be 300. And then again, we're just going to repeat every 360. Okay, so I just add 360 on each time. So 360 onto 60 to give me 420. 360 onto 300 to give me 660. Then on again, so 360 to 420 to give me 780. And add on to 660 to give me 1020. Can't add any more, otherwise I'd go above my limit. Okay, then all we got to do is find x rather than 3x. So divide all of them by 3. So we will have 20 degrees, 100 degrees, 140, 220, 260, and 340 degrees. Again, check that all of our answers sit within our range, which they do, so we are happy. Okay. Second one, slightly harder just because it's got the linear expression in with our trig function this time instead. Okay, so first thing, as always, is to make sure we adjust our range first. So rather than x, I'm looking at 3x minus 10, which means to adjust all my values, I need to times by 3 and minus 10 from it. So my first one, times by 3 minus 10, will give me an initial range value of minus 10. Do the same to the other side, so 1080 times 3, subtract 10 off, will give me 530. Slightly different range to look at. Right, back to our equation, we're going to solve. So I inverse cos both sides, so I'll have 5x minus 10 equals cos to the minus 1 of minus 0.4. So 3x minus 10 must equal 113.6 degrees. Now you may have used different levels of accuracy, guys. I would tend to use just one decimal place just to make it a little bit easier. So we know 3x minus 10 is 113.6. Again, that's only the principal value. Think about what cos looks like. So I have my cos bucket. Now be very careful because we're actually going through minus 10 now instead. So we have got a little bit further back this way, but we'll see what happens with that to see if it really makes any difference. Okay. Now, because we're looking at cos, again, the repetition is 360 minus x. So if my first value is going to be down here somewhere at 113.6, I'll do 360 minus that to get my second value. Okay. So the second value should be 246.4. And then we know, again, same as with sine, we repeat every 360. So I add 360 onto both. So I add 360 onto 113.6, gives me 473.6. If I add 360 onto 246.4, okay, I'm going to go above my 530 limit. So I'm not going to be interested in that one. Okay, so we're always measuring against that upper limit. Now, we do need to just double check that we can't get a value lower. Okay, because I've got a minus 10 in here that I need to check. Well, if I think about what this looks like, if I just draw the other side of my curve, it is worth checking this. To find this value here, okay, if that's 113.6, the distance in here, that distance there must be 113.6. So this value is minus 113, which is way out of our range. But it is always worth double checking. Again, because we've got a linear equation, we've now got effectively 3 mini equations we need to solve. So for each one, So for the first one, to find x, I'm going to add 10 to it and then divide it by 3. So I should get an answer of 41.2. Same with the next one, where I will end up with 85.5. And the last one should be 161.2. Okay. Make sure you've checked them, guys. If you're still not sure, please have a go at some more first. Okay. But what I want you to do now is go back on to Show My Homework and look at exercise 10E and the questions that I've asked you to do. Okay, there will also be the mark scheme. Make sure you mark them and email me if you need any help.